Welcome back to Educator.com. Introduction to C++. Today we are going to loop. Okay, looping is involved with branching. We've covered branching already, but it's a very important type of branching where you branch back to the beginning, do something over again. In early computers, there was an if statement and then go to another line. But we try not to use go-tos anymore. It's still in the language, but it's usable if you need it. Generally, you don't use go-to. We have a number of constructs that we use for looping. We have the while loop, a do while, a for loop, and there's ways of breaking out of a loop, and there's a way of repeating a loop. And of course, we have loops inside of other loops. Now, the difference that we're going to discuss is the while loop checks the condition before going into the loop. Do while checks the condition after going into the loop. A for loop can be used like a while loop. It's usually used for counting loop, but we're going to discuss all of this in a few minutes. Now we've seen code blocks where we have our open brace, we have some code, and we have the closing brace. And we've used those to create a branch. So if A is less than 10, then we will run this code between the braces. If it's not less than 10, then we'll go into the else clause. Now what we're looking at is a looping branch. So we will run that same block again and again and again as many times as necessary. So here we have a quick example. We're setting K and A to 0, setting B to 1, and we're going to ask the user for the value of M. And so we're going to increment K using the increment operator. We're going to add that new value of K to A. We're going to multiply B by that value. And then if K, our counter, is less than M that was entered, we will go back and we will run this block again. So like if M is 3, we'll change this from 0, we'll change it to 1. 0 plus 1 is 1. 1 times 1 is still 1. And 1 is less than 3. We go back around. Now we increment this again, it's 2. Now we have 1 plus 2 is 3. 1 times 2 is 2. And 2 is still less than 3, so we go back around, we make this 3. So now I lost track of what A should be, but we're adding 3 to it. So I think that makes it 6. You'll have to write this out for your homework and test to see if I did this correctly. And then B gets multiplied by the new value of 3, which I believe is also 6. But if we were to go continue with 4, then we would get 10, and 4 times 6 would be 24. And so depending on what was entered for M, we will loop that many times based on K being incremented. Now, in early computing, all we had was a go-to statement. So we had that same code we just saw. So if J was less than 10, well, not the same exact, but something similar, we would go back to here. And at the end of it, we would output everything. And the reason why go-to fell into disfavor is people would sprinkle code with go-tos all over the place. We'd have a go-to in here, we'd have a test, we'd go-to over there, we'd have a test, we'd go-to up here. The code got very complicated very quickly, and the term used for it disparagingly was called spaghetti code. So if we avoid using the go-to, for the most part, we can avoid writing spaghetti code. So one of the first construct we're going to look at is the while loop. It's a pre-test, and it's just a basic loop. It performs a code block repeatedly. Now, I mentioned before, code block can be replaced with a single line of code. You're not going to see that for the most part in these lessons, because I think you should get in the habit of always putting things inside your code block. Even if you could have one line, it's very often much better just go ahead and make a code block out of it anyway. So what the while loop does, it tests the termination expression, and that's your expression that's in the parentheses of the while loop. It tests it to see if it's true. And it does this test before each loop through the code block. So first thing it does, it has an expression here. Is A greater than 10? Is G greater than Q? Whatever. If it's true, then it goes into the loop. If it's false, it skips over that code block and continues on with the rest of the program. Now, one of the consequences of that, if the expression is false when you first hit this while, this code in here will not get executed at all. So that's one of the things mentioned right here. So you have to be careful. Actually, it's something you very often you do want something like that. You have an expression that evaluates something, and if it turns out it's not true, you don't need to use this code. You skip over it. If it is true, you go into the code and you stay in that loop until that expression is no longer true. Now, there's also do while, which is a slightly different. It's the same type of thing. It's still a basic loop. Runs the code block repeatedly. The difference between the regular while is the test is done after the loop, and one of the consequences is that the code inside the code block will always be executed at least once, because it doesn't test the expression until after it gets to the end of the code block. So then if this expression is false, it'll just drop down to the rest of the program. If it's true, then it will loop back. Now, this is an excellent choice for an interactive program. With languages that don't have this type of expression, you very often will see they'll have a get the value that we're going to test against. Then they'll go into the while expression because it has to test it first. And then at the end of the while loop, it will get that value again. Using the do while, you don't have to worry about that. You just run through your code and then check it at the end. So right here we have a guessing game. Guess the number is printed to the user. And we initialize the guess to 0. We get the guess from the user. Now the correct answer in this particular example is 7. If the user guesses 7, we print out right, and then we will exit. The reason why we'll exit is because the expression here is a guess that it's not correct. So if it's not correct, so in other words, if they guessed 7 is not equal to 7, so this will be false. And because it's not true, it will drop down. If it is true, two things will happen. At this point, the guess is not correct. So we'll go into the else clause, and we'll print out wrong. Ask the user, do you want to guess again? And we'll get their answer. And they'll answer either Y or something else. So if the answer is their guess was incorrect and they responded yes, then the while loop will go back and run that code again. So they have another chance to guess the number, and they can stay in this loop as long as they feel like it, or until they guess the answer correctly. Then they'll exit out of the loop. Now our last loop that we'll look at is the for loop. It's mostly used for counting. So you have a very specific number of times that you want to run through this loop. You want to go from 1 to 10. We want to run this loop 100 times. We want to ask how many times we run this loop. We get that into a variable, and then we loop in there until we hit that variable value. The syntax is just a little bit tricky, but after a little bit of use, you'll get used to it. We have the for keyword, open parentheses. Then we have 3 expressions separated by semicolons. The first expression initializes the variable, such as I equals 0. Your second is your termination expression. That will be tested. As long as this expression is true, you will stay in the for loop. So, such as I is less than 10. Well, when you first start, of course, 0 is less than 10, so you'll go through it. And your final expression is your increment counting. Now, there are other official names for this, and there's a ton of ways of using this, but this is your most typical way, is increment your looping variable. So, after it's gone through the block, it will increment I to the next variable. So it'll go from 0 to 1, and then so it'll execute this code, increment I, and then go back to the beginning again. Is 1 less than 10? Yes. So we'll run this code again. So we'll stay in this loop, incrementing I, until finally I will be equal to 10. So 10 is not less, 10 is not less than 10. It's equal to 10. So this expression becomes false, and the code drops out to the rest of the code. So here's your most typical example right here. We're counting from 0, inclusive, to some maximum, exclusive. So we start at 0, and we're going to continue until it is equal to the max. It won't be equal to max. When it reaches max, it will jump out of the code. And we'll have a little bit more discussion later on why that's typically done in C and C++. But right now, just remember you want to do, you're starting at 0. Computers start at 0. People start at 1. But we're in a computer, so we start at 0. And we count until the count reaches max, and then we increment the count, and then we perform some code right here. So if max is equal to 10, we'll go through this 10 times. If max is equal to 100, we'll go through it 100 times, however many times is necessary. In C++, added a feature which is very useful to the original C construct, which is the ability to declare your variable inside the for loop. Now this gives you the ability to isolate this for loop code from the rest of your code. No other part of your application will have access to this variable except on the inside of this for loop. So those are the rules of scope, because outside, if you remember from our previous discussion, outside of the block, which is right here, you cannot see any variable that's declared inside the block. And so this declares it right there for the for loop. It's a special case. It's very useful. Now, for loop is almost identical to a while with a few exceptions. Here's an example of we're getting a factorial. So we start I at 2 until it's less than or equal to the number that we're getting the factorial of. And we are taking I and multiplying it by the factorial. In case you're not aware, for example, 6 factorial, that's the way it's designated, is equal to 1 times 2 times 3 times 4 times 5 times 6. And whatever this results in is the factorial of 6. And that's what this will calculate. Now, the equivalent while loop, we start at 1, just like we're doing here. We're initializing I to 2, just like we're doing here. Here's our termination expression, just like here. And the loop incrementer is inside the while loop. Other than that, the inside of the block of code is the same. Why do people use the for loop instead of the while loop? This notation is a little bit easier to understand. It's all right up in the front. As soon as you hit it, you know right away, okay, we're going to be doing this some number of times. Sometimes you'll see up here code plus equals 2 because they want to increment the incrementer by 2 instead of by 1. And that's all visible at the very first line of the for statement. Whereas in the while statement, you have to read the code until you get to that final closing brace to find out if the programmer even remembered to put the incrementer in there. That's been known to happen. You get some strange bugs such as infinite loops if you don't remember that. Now, there's a special command called break, which allows you, it's like a goto, except it's controlled. The goto, you can go anywhere, which causes all kinds of nightmares. The break goes to the end of the code block that it's in. So it's very great. It's useful when you need to do a premature loop exit. It's very often used. You say, okay, let's do something, test the success. If it's successful, we keep going. If it's not successful, then there's no sense in going on with the rest of this code block. We'll just exit to the end. So right now we have, if both expression 1 and expression 2 are true, code 1 will execute, followed by code 3. Because the expression 1 true means we go into the block, and we execute code 1. Expression 2 is true, we break out of that block and skip over code 2. And at the end of it, we go on and run code 3. Now, probably the most notorious example is the switch statement. The cases on the switch statement, as we discussed in our last lesson, if you don't have a break, the code will just fall through straight down. If that's what you intended, occasionally it's what you intend. You've got some special code that you have for 10, and the same code is used for 20. So we'll just do our 10 code, and then we'll fall through into the 20 code. Very often that's a mistake. Very often that's difficult to understand and read for the programmer, so it's not a good idea except under special circumstances. But normally you will have a break after each case, and that will break. So you'll do the code for that specific case, and then you'll break down to the end of the switch statement. And as I mentioned briefly, it's great for error testing. So we have the end of this block is way down someplace. So we've got some code. If it fails, break out of this loop. Have some more code. If that fails, break out of this loop. So you can have multiple tests checking for your alternative to this would be to have nested ifs. And if you indent each one, your code will get very unreadable very quickly. So instead, you use the break statement whenever you test for success and it fails. Now, the other way of getting out of a loop or not getting out of a loop is continue. Go back to the beginning of the loop. So it allows you to restart a loop. So for the for loop, it will restart, but it will still increment the counter variable. So here we have expression 1, code 1. If expression 2 is true, we continue back to this beginning of the block and we do code 1 again. So we have a sort of a mini loop here until such time as this expression is false, and then proceeds on to the rest of code 2. So as long as both of these expressions are true, code 2 will not execute. If expression 1 becomes false first, then code 2 will never be executed. It'll just exit out of the while loop. But when expression 2 becomes false after executing code 1, then we can go and execute code 2. And then when this is false, then we exit the while loop. Now, a little bit of a caution with the continue. If you're using a for loop, you're fine. This will print out, this will print IDX before 5. IDX, if it's greater than 5, will continue. So we'll print this one, we'll print that one. And at the point IDX becomes greater than 5, we will stop printing this one and just keep looping here. Which is great because the for loop doesn't exactly run this increment counter down here. It does it after it does it at the loop, but the continue will execute this for each loop. Now here we have an infinite loop because we're doing the for loop in a while instead. So we have your I++ at the bottom. Now this continue will go back up here and never not hit this IDX++. So this loop counter, as soon as this hits 5, this bit of code here will never get executed again. And since IDX never gets incremented, it'll never be equal or greater than 10, so you'll have an infinite loop. And you can try that. That's a very good homework assignment to try that out, see what happens, and you get to practice interrupting your code when it has an infinite loop. Now, a very important thing with loops is have nested loops, loops inside of loops. Our best example we have is a loop for employees. It says, do we have more employees? Yes, we have more employees. Let's get an employee. Let's process that employee. Now, this employee's got a job to do. He's got a number of jobs to do. So as long as we have more jobs for this employee, let's process that task for this employee and then go get the next task for this employee. So we will stay in this nested loop as long as this employee has more tasks to process. When it's finished, this will be false. We'll drop down here and then get the next employee. So we'll be in this loop as long as there are more employees. We process the employee and then get the task for that employee. Now, a typical bug with a nested loop is to have either the counter or the expression be the same for both the outer loop and the inner loop. As you see down here, this will not work the way you think it will work unless you recognize right away that what it's going to do is print the outer 0 and then print the inner 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it comes over here, it increment k from 10 to 11 and comes up here and it drops out of this loop. This is a case where the programmer probably intended to do the outer loop 10 times, and for each iteration in the outer loop, the inner loop would also run 10 times. So this code inside should run 100 times, 10 times for the outer and then 10 times each for the inner. But since the programmer made this mistake of using both the same expression and the same counter, he got results he wasn't expecting. Now here we have some more looped loops. Now one thing to keep in mind, if each time you put an inner loop, it will run that many times for each time its outer loop runs. Now you can do this a lot of times. You can have a loop and a loop and a loop and a loop and a loop, and each one of those is going to be multiplied. So, obviously that may be what you expected to do, and maybe exactly what you wanted to do, but don't just throw loops in there because it's fun. Because each time you're adding a lot of processing. So here we have a matrix example. We're going from column to the max number of columns, and we're doing some initial processing for each column. Then we go into the matrix. We're starting row. And my pen has died again. There it goes. So you're going, I fixed it. You're going for each row. So let's draw a little matrix here. So these are the columns. Here we've got 5 columns. And we've got 3 rows. So from 0 to 3 rows. So we want to process, when we're on row 0, we want to do whatever processing that we want to do for this row. And then while we're in that row, let's process each column. So here we're going from 0 to the max here, it happens to be 5. And we want to process the cell in that matrix. So when we start off, we go 0 and then 0, so we will process this one. And then we're advancing the column with that one. And then 3, 0, 1, 2, and then 3, and then 4. And then we go to 5. 5 is not less than 5. And so we drop out of the inner loop and advance to the next row. So now we have row 1. And inside row 1, we're going to get each column. And we'll process each one of those. And we run out of columns, we go down to the next row. Process each column. So the number of times this code inside the inner loop will run is going to be basically the number of times for the inner loop multiplied by the number of times for the outer loop, which, as you can see, makes perfect sense. There's 3 rows, 5 columns. There are 15 cells. You're going to be processing this 15 times. So one optimization technique you can use occasionally if you happen to notice it, if your logic says, well, I need a loop on the inside of this loop, but if you look at it, well, it doesn't really need to be inside that loop, let's take it out of the loop, then that's some code that will not be multiply executed over and over again unnecessarily. Now here is a loop. 99,999 bottles of beer on the wall. Take one down, pass it around, 99,998 bottles of beer on the wall. So you know what the exit condition for this loop is, right? That's when the singer gets killed. And that's it for today at educator.com. Thank you for listening, and I'll see you next time.